Boa tarde a todos. Estamos de volta. Espero que o vosso almoço tenha sido espetacular aqui na nossa cidade do Porto. Nós vamos receber agora o Norberto Leite, que veio de Madrid, trabalha na MongoDB. Eu demorei algum tempo, porque eu dizia DB, porque não sou da IT, então tenho esta dificuldade, mas aprendi hoje uma coisa nova. E vai-nos falar deste conceito e dos benefícios do uso do MongoDB. Obrigada.
Obrigado. First question, is anyone here has any problem with Portuguese? I do. I definitely have a problem with Portuguese because I live in Spain, so probably it's better for me to do it in English because people ask me to do it in English. And the other thing is that since I'm living in Madrid, or actually I'm living in Spain for so many time, it's probably that I don't know how to speak Portuguese anymore in terms of correctness. But that's not the purpose of the talk anyway. It's around MongoDB and how we can build, or what kind of advanced applications should we be thinking of when we are thinking about using MongoDB, or better saying, things that you probably don't know that MongoDB can do for you. So I'm going to give you guys a little bit of an introduction to Mongo. We will talk a little bit about general aspects of databases. So what kind of things should we be looking to when we're deciding which kind of database we're going to be using in our applications, and what kind of differences there are between the different types and flavors of it. We're also going to be looking into modern age software. What is that? Or if you guys are building any kind of modern age software in the beginning. And we're also going to be briefly speaking about a little bit about the available infrastructure that we have today, how different it is from our dad's infrastructure when we were building applications 10 years ago. So these are my contacts. Feel free to spam me as much as you want on questions related to MongoDB. Follow me on Twitter. I sometimes put some stuff there that's kind of relevant for whoever is interested on the technology. And yeah, and also I'm an asset of Mongo as well, so I have my own webpage there, so it's pretty cool. It's a forum, doesn't do anything, but always good to get that. So, first show of hands, who here knows a little bit about MongoDB? All right, cool. Who here, you don't need to stand up, but that's good. So, who else is actually working with MongoDB on a day-to-day basis? Okay, a little bit less. I didn't do anything, I'm sorry.
Is this?
Yeah, that's fine. So you guys probably heard a lot about MongoDB before. Some of you might have a little bit of experience with it. Not a lot of you guys have projects in production. Otherwise, I would know about it. Because I'm Portuguese, so I'm sniffing everything that people are doing with Mongo. This is all a hoax. I was talking here with a colleague, and he was asking, well, it's just a database. In the internals, it's running on SQL Server. Everyone knows that. So, but on top of that, actually MongoDB is a sniffer that goes into your laptop, you install it, and then it erases all your illicit content and your downloads and all that. So if you want to have a clean software, this is what you're going to do. MongoDB is a general purpose database. It's open source, so it means that you guys can build any type of application on it and not pay a dime, which is nice. It also changes the way that we organize and store data. We are very well acquainted with the tables and rows kind of architecture. Everyone knows how to do a SQL query, right? So here, who doesn't know what SQL select star from dual does? No one knows that, or no one actually ever tried it? Does anyone ever try select star from dual? Okay, what does it do? Absolutely nothing. So it's a useless thing ever. But it's the basic foundation of how we use the SQL language. We tell what we want and from where we're going to find it. Everyone in this room probably studied in university, and this is the way we've been taught how to extract things from databases, correct? Everyone agrees with that? Okay, cool. So I'm not saying any mistake. So what is this document-oriented databases? What things are different? And how can we organize data in a different shape and form? Who here works with object programming languages? So you know how to build documents, even though you don't know it. Documents are pretty much the same type of structures that we use in classes and in objects, or Python dictionaries, or Ruby hash maps, or PHP arrays. They are key value structures that we can set up in an hierarchical fashion, and we can interpret it as well as in the JSON format, which is the most well-known format for a document. We use that foundation to store information. There are a couple of reasons why we do that. First, because it's natural. Everyone will, if we give you a document, you will know immediately what it is. Second thing is much more suited to what we build today. And it's much more suited to a couple of other features and functionalities that we are going to discuss today. It is also, MongoDB, it is also a fully featured database. And that means that, we can kind of do anything with it. We have from one side all the rich queriness that we are used to use and used to have on our relational systems. We can do any kind of query on any kind of field and any kind of table, doing major joins and unions and all that, using our SQL model, correct? So MongoDB also allows you to do that. Different model, but it also allows you to express any kind of query on any kind of field. The other good thing about MongoDB is that it merges as well on the operational database the workload of analytics. So you have in SQL the general way of doing counts and group bys and all of that. So you are very familiar with having group by, whatever, so you can have all the averages, counts on, the BI workhorse of our databases. In MongoDB, we have MapReduce and aggregation framework to do exactly that. But we also have a couple of features which, most of the times, they don't come for free on the database, which is geospatial capabilities and full text search index. Now, we don't want to be a full text search engine, but we do think that it's nice to have that kind of indexation, that kind of queryability next to your data. Comes handy. And for simple things, it's very, very powerful. We are an open source project and product. We live and die for our community. And we have some numbers to show about it. We have 9 million downloads. Well, actually, we are more than 10 million by now, but that's a spoiler because we are going to announce 10 million something downloads in MongoDB World, which is next Monday. We have more than 250,000 people signing up for our education platform. Does anyone know about our education platform? Isn't it great? Is it bad or is it good? More or less? Okay. It's awesome, I can tell you that. And we also have a lot of people that just sign up for their free time to learn and share experiences on MongoDB. Some of them go to our online courses. I totally recommend you to go there. If you want to learn more about MongoDB, that's the best way to get good education and knowledge on the technology. We speak your language. Well, I speak your language, although I'm speaking in English, but we speak your programming language. We have a course designed for every single driver that we have. So from Ruby to Java to Python to C++, you have all of those things on our educational platform. But we are also local. Okay. So if you want to learn a little bit more about MongoDB, I urge you to sign up for the meetup page. We kind of meet up from time to time. When I come over and I do tech talks at these kind of conferences, we always try to get together to rally the troops and do a session explaining some component of MongoDB, or if you guys want to express some experience that you had with Mongo, it's a good way to share the knowledge and share the love. And I don't know if you realize, so if you checked into my role, I'm technical evangelist, but I'm also Portuguese evangelist inside MongoDB. So my main function in the company is to spread the good deeds of Mongo and help people understand a little bit what this technology is. But more important than that is to spread good wine across the company. And there's a reason for that. We are a company. We have more or less 400 people on different roles and different responsibilities. We are spread across the world. We have offices that go from Sydney to New York, Dublin, Madrid, Milan, and Madrid is my home. Palo Alto, we are quite spread to give you a global support and a global presence. We have some money to burn on wine as well, which is good. And the main idea around MongoDB is that we get more and more people to use MongoDB, to actually contribute back, and have more and more projects on it. And we are a business. Well, we are not just this ordinary business. We are in the business of making sure that the majority of people that today are frustrated because of their infrastructure, which are slow, or they are having a lot of pain setting up for this new age of software, get better satisfaction. Get faster development, get faster features into their applications, and get more out of their ideas. So let's focus a little bit on enabling new applications, because this talk is around how we can do advanced applications with MongoDB. But in essence, our major deal or our business is to create applications that before were probably either impossible, very expensive, or just would take too much time. I'm pretty sure that a lot of you here have been dealing with a project that probably was not fitted for the technology stack that you're using, either because it would take a lot of time to do it, either because it was very, very complicated to scale them, or just it was a mashup of code and no one would understand it. Has anyone faced that reality? I know a couple of you here. I worked with you, so I know that we've been in that kind of situation before. Some Hungarian people throwing up some C++ code that no one understood. Yeah? Okay. And we needed to deal with a big, big petabyte kind of database. I know you guys are smiling. So back then, we didn't have too many options. It was a closed project. We had a lot of data. That maintainable, unmaintainable code needed to be maintained and needed the infrastructure to be just spread out. But we didn't also have the choices that we have today. So let's think about those kind of problems when we have a lot of code, a lot of complicated nested tables, a diagram of entity relationship mappings that will cover that wall over there. And let's think about ways that we could actually improve the way that we deal with that data. And you want to do it in an agile and scalable way, obviously. That's the major deal. We don't want to do exactly the same way as before. For that, we can use SQL Server. That's fine. So let's talk a little bit just on databases. What are the main characteristics of each kind of flavor? And what kind of things do we have today that actually makes us more productive and happier? From one side, we have relational systems. Everyone knows it, correct? I asked you what the SQL star from Dual does, and does absolutely nothing. It's great. But we all know how to express our queryability there. We all learn it from school. We might not do it very well, because sometimes we do joins without an index on it. I'm guilty. I've done it before. We probably sometimes we don't create the right index because they are not selective enough. But we have that option. And we know we have techniques to learn how to deal with that kind of expressivity. These have a strong consistency model. They are very rigid by that, but they are very strict as well. So it means that we have confidence on if we send something to be written into the database, we can guarantee that it's going to be there. There's transactions, there's a lot of joins, there's a lot of things that we learn to manage and deal with data. We even have store procedures, which are great, correct? Everyone likes store procedures. You guys do? Get the no. So in the morning, we had a session from our Portuguese eBay member where he stole a phrase that I usually do, which is, there's a special place in hell for people that invent the store procedures. He did it in a different topic, but it kind of applies in the same way. So we all know how these things work. Great. But we also know that sometimes we need flexibility. And we also know that for today's applications, and we're going to see a couple of them, we probably need a lot of scalability and performance. These things tend to be the slowest part of our application. Sometimes they are perceived as necessary evils, because they are. Unfortunately, we don't have constant RAM for all of our data, because if we would have, and constant uptime, because if we would have that, we wouldn't need anything like the database. We wouldn't need to persist data. If everything would fit in RAM, if everything would fit there and never failed, Great. Why would we need databases, correct? But the reality is that we don't have that, and we still need to store data. Sometimes storing data in relational systems, it's hard. It's really, really hard, especially about the very different data types that we handle, and for the fact that once we define it, changing that is constantly a pain. But it's like any piece of technology, like automobile tires. You have one tire, you replace it by another brand, it kind of does exactly the same thing. Probably sometimes you need to think about efficiency of the tires, if they are going to last longer, if they are going to be rolling faster. All those things come into play. We have to think about that our relational systems, they are very well built for a different kind of architecture and a different kind of computational environment than today. Today we have petabytes of data. There's lots of websites out there that share cat pictures. Those cat pictures need to be stored. There's a lot of websites that share information between ourselves, comments, tags, messages. Those things cost $16 billion companies. So these are important information. It's very variable. It's different data types. And one thing that is constantly happening, it changes very, very, very often. So if we have a strict model to handle all of this data, my perception of reality tends to be something like this. Does that mean that we don't need those relational systems anymore? They don't work anymore? Well, yeah, you're fine, they work. But probably they are not fitted to what you want to do. You can drive that. I can guarantee you that if you have a guy handling the handle over there, he will not let go. Because if he lets go, it's going to be projected. But probably if you want to go 100 miles per hour, it's not going to be holding it. No way we can do it. So that will be impossible. So a little bit of the development that we do today, especially for this new type of architectures, new data types, extra amount of data that we need to handle, if we're using the relational systems, we're probably going to be in a situation like this. We have to have a guy holding a handle. Otherwise, something will break. And we can't go too fast. On the other hand, we have NoSQL technology, which is designed to be scalable, designed to be extremely performant. Millions and millions of inserts per second, right? That's the message. That's the promise. Very, very flexible systems. But they have trade-offs. Generally, they don't allow us to do that much of a query. Well, key value stores are great for writing. But once we have data there, we want to extract it in some way. Just the key value store probably is not the best option. Sometimes we need strong consistency to make sure that what we do is actually correct. We can have multi-master systems, but we don't know if it's in one node, if in another, then we need to read from all of them, and then we waste time. But for some use cases, these things are extremely, extremely valuable and extremely useful. So I kind of apply them to this. I don't know if you guys know this, and if you don't know, that's fine, no worries. But if you are a physics major, you probably know about the Heisenberg uncertainty principle. And that's just a little bit what NoSQL database can be associated with. Okay? It is fine. Sometimes I don't know how to use it or what to use it for. And people start asking, well, does it really exist? It does. But you need to think about extremely well what you want to do with it to make sure that it fits your needs. Well, what if we had another alternative that we can merge these two different realities together? Well, we at MongoDB, we think we can do that. Not only because we add up all the strong consistency, secondary indexation, a good, rich query model that you can use, but we also merge with all the flexibility and scalability that NoSQL technology actually does for us. So we want to be that nexus architecture that enables any kind of application with any kind of workload for your modern age software. In essence, we want to be the bridge between both realities. Either we do it well, or this is going to be a hoax, and it's going to be all running on SQL Server, as everyone knows. But that's our goal. And today, I think we have a very good model to get there. Let's talk a little bit about what kind of applications are we building today. Well, first of all, we are building applications that are mobile, social. They do a lot of different data. They constantly change. They are iterating ever and ever faster. And they cannot afford to miss data in terms of, I cannot discard anything, because that today probably is junk, but tomorrow it's going to give me insights on how users are using my information, what kind of data is actually relevant. That's not for today. That's probably for tomorrow. It's probably when you grow. And another thing that you need is that you have to be prepared for catastrophic success. That's a quote from one of our customers. They are not building massive scale systems for the first launch, but they want to be prepared once they have a hit, that the system they are building is capable of holding that data, holding all that water that's coming down the dam. So there's a couple of characteristics that we need to focus our applications on. First of all, lots and lots and lots of data. Data is the fuel of the 21st century. Has anyone ever heard this before? More or less? In NoSQL, some people say it's the combustion engine. It's the thing that actually makes you get there, makes you run on it, makes you extract value out of it. We are focused on having always uptime on our applications. We don't know where users are coming from. Some guys are in the other side of the planet accessing services that we just built. Other people are just constantly checking their email every day. Do you think about Google without downtime? Without time, actually? Has everyone thought about if Google goes down for 2 hours on Gmail, what that happens? Do you want to do your shop, so you want to build old technology or want to be the next Google? That's the question you have to have. And if you want to be the next Google, this is one of the things you need to maintain in mind. No downtime. Nothing can fail. And the other thing is, well, iterate faster, much faster than before. If we go into a room for 3 months to make a nice schema design for our application, when we come back, the world has changed twice. And we all know this. We are all looking for agile methodologies. We are all looking for the new, fastest pace way of building software. This is extremely, extremely important for our business today. So the idea behind all of these 3 main characteristics is that we can build better businesses, new businesses, different businesses, with higher growth, without going bankrupt, basically. That's the 3 main objectives of this new type of applications that we're building today. A few examples like data consolidation. Who here works for a big organization? Like, when I say big, is bigger than Bash, for example. Bigger than Banco Espírito Santo. No one? They are quite small these days. They went bankrupt. So we probably all, if we have a job, we probably have working for a bigger organization. Let's say we work for an organization that has a substantial amount of systems to maintain. They have a CRM system, the BI system, a trading system, a HR system. How many of you think that that data should and needs to be crossed for some business need? Can I make assumptions on my users if I have a completely siloed out, purchasing system? Do I know which kind of customers do I have if I have a CRM that only manages the communications and doesn't manage the kind of bookings they are doing in my web front, for example? Should I have that data together? And how should we manage that data? Is it possible just to build a consensus relational system that accommodates all of those different all of those different realities? Or we just divide to conquer and we buy some software, steal one of the things and another thing and another thing. And how do we merge all of that information? Well, a lot of our biggest customers are looking into systems like this because they are probably having thousands of instances with data that needs to be consolidated in one single point, or at least known as a single point of that data, like single view of the customer, single view of the product, single view of the service. But we need to get all this kind of information together in one single repository. We're also helping people, especially in the chemical and pharmaceutical industries, to find new components. You know, molecules will have fingerprints. Those fingerprints might be further away from each other depending on the way that you analyze them. Millions and millions and millions of compounds. And you just want to find that combination that's probably either an allergic reactor or some kind of drug that's very, very similar to fight cancer. Those are the things that we're looking into to make sure that people can do much, much more intelligent decisions when today going for research, for example. The same thing on biomedical and big data genomics. How different do you think you guys are from me? I mean, very different, obviously. You're bright people, you know what you're doing, all those things. But in terms of molecular and genomic differences, it's 0.001%. How much data do you think we can extract out of that 0.001%? Shitloads of Oracle instances, I can guarantee you. And the problem with those is that it's not just storing that in data. It's what we do with it. What kind of queries can we do with it? That is extremely important. Otherwise, we just have a dumb lake of data, and we can't pull anything out of it. We can't build applications, operational applications that people, researchers can do. Okay, if I combine this gene with that gene, what's the implication on it? And obviously, today, we have a lot of IoT kind of use cases. Does anyone here work on IoT? So our first customer here in Portugal actually was working on this before IoT was actually a thing. They had this nice application that allows them or their customers to track what their truck drivers were doing with the trucks. How heavy they would step on the pedal for acceleration and fuel consumption, if they were stealing fuel from the truck or not. Believe it, people will do that. They will fill it in and then suck it up and put it in their car. They would like to know if the truck driver actually was going through the course established. So they wanted to know if A to B and the course they were taking was exactly the one that was predefined. And this will give us, and MongoDB will give it that from the geospatial capabilities. They wanted to know if, for example, if I need to dispatch this box over here to, I don't know, to Lisbon, for example, how would I get there faster? Who would be the driver that would get me there faster and more efficiently? Filling in the rules, making sure that he was doing all the speed limits and so on. This is one of the applications that was built here. Well, not here, but in Portugal. It was extremely cool. Before IoT was actually a thing. And it was running all in MongoDB. So is it just for fancy applications? Do I need to have a use case for biomedical research or genomics analytics or IoT? Well, not always, not necessarily. But you should think about a couple of questions before you approach MongoDB. Did I ever have to change my schema? If I did, probably you should look into something that gives you flexibility. Did I ever have to have some kind of geospatial capabilities out of the box, just heading up an index? If I did, probably MongoDB would be a solution for it. Did I ever have to iterate faster than ever before? Flexible schemas, new data types. If I did, probably MongoDB can help you. Let's visualize a little bit of an example. So, I want to build a simple quotes, they figure code, well, George Jesus quotes online. So I want to, get from the web all different quotes from George Jesus. So we can start with the first one, which is like, I don't know. I'll have him referencing someone. In this case, I'll have him Toto Peggy, which we all love here, right? So it's a very good coach. And we can structure data as we go. So we're extracting that data from a website. The website will set up the dates as, you know, a string, not necessarily a very good format, but, you know, it's useful. And some of them will have the quotes separated by different lines, so we can reference them back in the future. Some other website will have some other kind of more simplistic one, right? You know, they won the championship, those bastards. Sorry if anyone here from Benfica, but you can see that I'm not. And, you know, which is good. They are the best. Great. But in another website, and this is after Saturday or next Sunday, I do to believe, that we have a much more structured data. Oh, it doesn't show well. So the date will have a different data time. The whole idea is for us to adjust our application so we can collect all of these different data formats into one single database, and we can elaborate very complex applications with it. We have that power. We have that flexibility. And why do we need that flexibility? Well, you know, who here is working on mobile? Yeah, some of you? OK, mobile is hard. Well, it can be hard. It's hard because we have a lot of new data. It's hard because we have scaling problems sometimes, and because we have to iterate faster and faster than ever before. MongoDB can help, or it's designed to help, because it allows you to have modular schemas, flexible schemas, and very good performance. And obviously it has a horizontal scalability model that allows us to grow as our application becomes more successful. Does anyone here work on catalogs, e-commerce websites, something like that? Or, I don't know, patient catalogs, inventories, stuff like that. They can be hard as well. Sometimes they are built on top of stagnant architectures. They are very, very hard to change. Sometimes we have to do with a lot of work just to get around, you know, the different variability of the data that we hold there. And sometimes we have trade-offs in terms of functionality. Well, MongoDB can also help because we want to build the impossible. We want to do it fast. We want to make sure that our query language and aggregation framework are there to support any kind of feature that you might want to do. Same thing for single view of the customer, consolidating a lot of data. It's hard because it's a lot of data, different sources, changing constantly. We also have a model for that. And we also have a lot of use cases that I invite you all to go to our website to look for and to see how we've been managing all those systems. But there are many, many more. There are systems around telcos. There are systems that have been built for financial institutions, fintech, finserv, high-tech, healthcare. A lot of different use cases on a lot of different business areas and a lot of different models of workloads in different organizations. Definitely, it's a general purpose database that I bet you that you can build anything on it and scale at the same time. And also, we shouldn't forget about one key component. How many of us today is working with the cloud? How many of you would like to work with the cloud? Well, maybe some of us wouldn't like to work with the cloud, but we don't have any other option because that's the way that we are going to deploy systems in the future. Containerization, virtualization, all of those things. So we need to think as well on the infrastructure that we have available. If we go into the term infrastructure, we have to look into what it means, and it's basically the basic structures and equipment that people, organizations, countries, regions work to function properly. And this is extremely important part, function properly. We should be using these kinds of things to run our cars, or these kinds of things to do the networks, water piping into our cities. Don't get me wrong, those things work. And they are here, built by the Romans. So that shit actually works very well. And it's been standing here for a while now. So don't get me wrong, these things actually been proven technology. They do their job. But I now want to ask you, do you think they are still serving the same purpose? Today, they are serving a different kind of purpose. They are just basically, historical monuments that people go and take pictures out of them. This is what I want Oracle to be looking like in the future. So, yeah, some kind of instances that we can take a picture and say, yeah, I used to work with that. See, oh, Dad, you're so old. That's what I want to hear. So, and we have a lot of different infrastructure today that is meant for this particular purpose: deliver fast, speedier, more intuitively, and with much more engagement than before. We have, oh, sorry, making a mistake here. This is actually this thing, right? Old-fashioned guy. So we have a lot of bandwidth nowadays. We have networks that are reliable as ever. We have virtualized infrastructure that we should use and abuse it. We have lots of different providers for infrastructure: Google, Amazon, Azure. So we should use them because they are here to serve a function. It's get us faster to market. And don't get any doubt about that. They work. A lot of good businesses out there making multi-million-dollar deals. A lot of them inflated, as we all know. But they are a baseline foundation for what we have today. But we don't just have infrastructure as a service. We have platform as a service. I want to go faster. I don't want to care about the infrastructure itself. I just want to write code. Great. We have services for that. And also, I just don't want to take care of all that API complexity of sending SMSs through the gateway or storing even databases. I can hire someone to take care of all of that for me. And I can concentrate only on making bugs, because this is what we do. Okay? So we should take benefit of all of these 5 pillars of our modern infrastructure: virtualized, redundant, scalable, ready to speed up our development processes, making sure that we can be as diverse as possible, as in many regions as we used not to be able to do it. Nowadays, if we want to launch some service, clone of what we're building here in Portugal, in the US, is as simple as putting there an instance running on Amazon, and there we go. So think about that when we are dealing with our new generation of applications. So before I leave, and someone kicks me out, the whole purpose of all this new era of applications is that we have a lot of things that we can use today. We have choices that allows us to have different variations of how we build stuff, how we store stuff, how we deploy stuff. Our applications are faster paced than ever, more demanding than ever, and more enriching and enriching more audiences than ever. And this is something we should take advantage of. Don't be shy. Don't be limited to what you know. Just expand. Make sure big bets are made. Risk benefit. Constant change is a constant and should be embraced. People are not too comfortable with change. It's normal. We set up our little castles, and this is what we know. Don't do that. Change is good. And change is the thing that allows us to improve, make it better. Or make it worse, but correct it after. And MongoDB is here to help you get most of all of your ideas faster paced, more iteratively, more dynamic, more flexible. And you all know Fernando Pessoa or Álvaro Campos. You used to say that ignorance is liberating. Well, I also think that knowledge and confidence and ability to change and be happy with what we do is also liberating. So don't be frustrated because your SQL server is not running as much as you can. You have options today. You can change. Just give it a shot. Go for it. Take bets. And I'll see you around.